Okay, so I'm building this game called Snake Warriors. It's at least at the time, it's still a basic Snake game. I'm trying to um, improve it um, a little bit every day, but right now it's just a very simple Snake game. You have to pick up the little foods and use core points until you lose if you bump into a wall or if you bump into yourself. Clearly nothing strange or anything. So, well, interesting to say that you can run it mobile and it will work by sliding or swiping instead of using the keys, which is, I think, pretty nice. In particular, what I wanted to share today is something that I found quite interesting when I was making the first steps with this game, which is the fact that I had to use something called input buffer. I didn't know it was called input buffer because I don't work on the gaming industry, but researching a little bit, I found out it is an input buffer. So basically the problem that I was trying to solve was that sometimes when you're playing the game, you just want to like turn quickly, like for example, down left, down right, up left, up right, and so on. And that was not behaving as I wanted before. So let me see if I can replicate how it was working so that you can get an idea of the problem that I was facing. Okay, so to better show what an input buffer does, I have a version here that doesn't have the input buffer or has like a broken input buffer. So here, if I start the game, I can move around, that's fine. But if, for example, I try to press two inputs very, very quickly, look what happens. See? Doesn't turn. Sometimes it works, sometimes it doesn't. I'm just pressing down left or down right. If I go too fast, it doesn't work. If I go a little bit slower, it might work, but it's really hard to play. It's definitely not what you want when you're playing. You want to be able to press very, very quickly down left, down right, or any combination of keys. So let's see how the input buffer is helping here. If I have the snake, let's say the current direction is right, so it's moving to the right, I update the position of the snake once every frame. That will be around 60 frames per second on most computers. But if I press very, very quickly, what will happen is that, let's say I press down, so the direction for a moment will be down, but maybe the snake position doesn't get to update before I turn the direction to the left. So let's go again. The snake is moving right, or the current direction is right. So I press down, the direction is down, and before the next update, I try to set the direction to left. And what will happen is when the snake tries to calculate the new position, it says, okay, my current direction is right, and now they are trying to make me go left, and that will be ignored because that's how I coded it. Obviously, you shouldn't be able to turn 180 degrees. So you shouldn't be able to turn from right to left right away. So how does an input buffer solve this issue? What an input buffer does is accumulate different inputs. So in this case, what I can do is when I press down, I tell the input buffer to add an input down, and I can show the code in a few seconds. But basically what you're saying is, okay, let's add the change of direction to, or the, like the, yeah, whatever, like the input down event. And then when I press left, I add the input left event. And that's independent on the update or the frames per second. Whenever I press a key, I add the key press to the input buffer. Now, when the time comes to update the snake's state, what I do is read one event from the input buffer and just one event. So let's revisit how this works now. If the snake's direction was right, I press down left super quickly, even before the state gets to update. So in that case, my input buffer will have two events, down and left. Then when the state has to update, I read one element from the input buffer. So I say, okay, the first element is down. And that's it. So in the next frame, the snake will move down one square. And then when I read another input, the input will be left, but the snake will have moved down one square, and that turn will be allowed. So that's how, or one way, an input buffer can help you, and that is widely used in different games to allow pressing things quickly and sort of queuing more than one key press, despite if you get super picky, it shouldn't be allowed. We allow that with an input buffer so that the playability is better and it's a little less strict with the player. Now let's see how the input buffer works. It's pretty simple. I have an input buffer here. So this is it. It's just a queue. I implemented it with a class. So what you do is you can have a method add input and another method get input. I have a reset here for reasons that doesn't matter at the moment. But what I do is whenever I call add input, I push the input to the keys queue, and the get input picks up the first element and returns it. And how it is used, let's take a look. For example, let me see here. So, well, I have a main class here to organize like the life cycle of the application, but when the application starts, I create an input buffer, and then I have a swipe handler and a keyboard handler. Each of them will take care of swiping and handling the keyboard because it works on mobile and desktop. But let's take a look at the keyboard handler. The keyboard handler adds an event listener for key down, and whenever I press a key, well, depending on the key, if it's a roll down, S or capital S, I add the input and that's it. So I can press keys and those will be immediately added to the input buffer. And then when I update, here's the main loop of the game. So game update, and render. Render is just using React to render things to the DOM in an efficient way. I'm just using React just for rendering, and I'm holding the state with my own code. And then, well, request animation frame just calls the loop again. So if I go to the update game method, a couple of things are happening, but the important bit is here. I'm calling the update on the snake class, which has all the logic, and one of the arguments that are sent to the update method of the snake is a read input function that the snake will call whenever it needs to read an input. So what this function does is call get input on the input handler. So whenever the snake needs to update and needs to check what was the input of the player, it will call this function here, which will get one input from the input buffer, and it will be processed in any way it needs to be processed. So if we dive deeper into update method, let's see. Okay, here are a couple of guard clauses. This is the management of the steps per second, because I don't want the snake to rush and go super fast. But once all these finishes, the first thing that I do is handle the input, and here's where read input is called. I could technically pass the input buffer into the snake, but I prefer to just provide a read input function, so I keep it a little bit less decoupled. It didn't sound very good to like for the snake to be aware about the input buffer and all that. I think that the snake is the core of the game, and the input buffer is like a little less core than the snake. So it's good to avoid core things, knowing details about implementation details such as the input buffer. So, well, I guess that's it. I hope this helps understanding a little bit of the details about how you can write a game, how you can structure a game, and let me know what you think in the comments, and see you next time. Oh, and last but not least, you can play the game in snakewarriors.web.app. You will see the latest version of the game there. I'm updating it every week with new features. So right now you should be able to play on desktop, on mobile, and for the time being that's pretty much it. But I'm planning to add many new things, most notably multiplayer. That's why I called it Snake Warriors, but well, bear with me. I will keep on uploading updates and videos about how this works.